Okay, next section in our agenda is writing linear equations. So this will be your slope and your slope-intercept form and all of that stuff. So this should be review from Algebra 1. Alright, a reminder of the slope equation. If I give you 2 points, then you use y2 minus y1 over x2 minus x1. If I give you a graph, then you can use rise over run and just count the boxes. This is an equation that you have to know. I don't give it to you. Alright, so let's try a couple and make sure. Let's find the slope between the points. So we do y2 minus y1 over x2 minus x1 and then simplify. So you can also go 3 minus 6 over 2 minus 4. It will give you the same answer. There's just a little more simplifying to do. So either way you choose it, you'll be able to do it. Alright, let's do the second one. Let's do 0 minus negative 2 over negative 10 minus negative 1. And then simplify, and there's your slope. So you could go up to over 9 or down to right 9, whichever way it works out. Alright, to write the equation of a line, you're going to find the slope if you're not given it already. If you're already given the slope, then you can skip step 1, go straight to step 2. For step 2, you use the point slope form, plug in one point and one slope. Point slope form is probably the easiest way to do this because you can do all the algebra straight from it. So this is a form that you need to get familiar with. This is the one I start with every time. And then after you do point slope, you can go to step 3 and you can convert the equation as necessary to the correct form. This is the pathway to do these equations. From point slope, it goes to slope intercept, then it goes to standard form. And you'll see this after we do a couple examples. Alright, here's a reminder of point slope form. x1 and y1 come from the point that I give you in the problem. If I give you 2 points, then you get to pick which one you want to plug in. Just pick the easiest one and go with that. M is your slope, so you need to either find the slope and plug it in or just plug it in. Alright, so this is an equation that's actually in point slope form already. Okay, so we'll just write that out here. This is point slope form. We want to convert it, so we're going to take it all the way to standard form. So first thing, I need to get rid of these parentheses, so I'm going to distribute. Alright, and when I distribute, I get 4x plus 24. Then, to get slope-intercept form, I have to get y by itself, so I need to add 4 to both sides. So we're going to add 4 to the 24. Get 28. This is slope-intercept form. Okay, so that's the form that we could graph. That's the easiest one to graph. To get to standard form, I need to move the x back over with the y because standard form has x and y on the same side. So I'm going to subtract 4x from both sides. Alright, it's almost standard form. It's not quite there. The one thing with standard form that I'm kind of a stickler for is the x has to be positive. So we're going to multiply this whole equation by negative 1 so that we can get x to be positive. So that makes this 4x minus y equals negative 28. This is your standard form. Okay, another thing I'll do with standard form is we won't have any fractions. So we'll need to multiply by a denominator to get rid of fractions. Okay, this is the process that goes through. That's why we start with point slope form, because it just flows through. Okay, so let's try one start to finish. We're going to do an equation in slope-intercept form for the line through point P with slope of 3. So we'll start with point slope form. We'll do y minus y1 equals slope and then x minus x1. Okay, that's point slope form. We need to get it in slope-intercept, so we need to distribute. So we get 3x plus 3. And then we need to add 4 to both sides to get y by itself. So we get 3x plus 7. So this is our slope-intercept form. We could graph that and go on. Alright, this time we're going to standard form. So we have a slope of -1, point P. They give you a point and a slope, so you start with point slope form. So y minus y1 equals slope x minus x1. There's point slope form. Then we distribute. And then we subtract 4 to get y by itself. So now we have slope-intercept form. Now we need to add the x back to the other side to get x and y on the same side. And we have standard form. This time we don't have to multiply by anything because x is already positive. And there's no fractions over here, so we don't need to multiply by anything either. Alright, this time there's a little bit different. They gave us 2 points, and we want slope-intercept form. So we actually have to find the slope first. Okay, so we'll do y2 minus y1 over x2 minus x1. You notice that I started with point A as my x2 and y2. You can start with B as your x2 and y2. It doesn't matter either way. Alright, simplify. And you always want to reduce if you can. This one we can't reduce. Alright, point slope form. We'll do y minus, and we get to pick which point we get to use this time. I see 1s, and 1s are easier to work with, so I'm going to plug in point B. Okay, so y minus y1 equals slope x minus x1. Now we just have to do the work to get it to slope-intercept form. So we distribute, and even though there's fractions, we don't care. We do the same process. Okay, that's why I picked the 1s, because it's easier to multiply by 1. And then subtract 1 from both sides. And when you subtract 1 over here, you're subtracting 3 over 3. So this becomes plus 1/3. Alright, and that's your slope-intercept form. Had you used point A in your point slope form, you'll come out with the same answer. It doesn't matter either way. Alright, standard form, 2 points. So, gotta find the slope first. So we do y2 minus y1 over x2 minus x1. Reduce. And then we start plugging it in. It's point slope form, so you get to pick which one you want to do. I see a 0. Zeros are easier to plug in, so we're going to use that. So y minus y1 equals slope, and then x minus x1. So we already have y equals. We just have to distribute. Okay, so we distribute that. And then -3/2 times -5 is 15/2. Think of this 5 as over 1, multiply the tops together, multiply the bottoms together. So now we have slope-intercept form already. Now we're going to go to standard form, so we need to add the x back over. So we get 3/2 x plus y equals 15/2. Alright, the x is positive, so we don't have to take care of that, but there's fractions in our problem, so we're going to get rid of that. We need to multiply by 2 because 3/2 is like 1.5, so we need to double it to get it to a whole number. Same thing with 15/2, that's 7.5, so we need to double it to get it to a whole number. So we're going to multiply everything by 2, and we get 3x plus 2y equals 15, and that's your standard form. Either one of these are standard form. The bottom one is better standard form. Alright, what kind of lines are these? If you know your graph, y equals 3 is a horizontal line. Okay, these are the ones that we like to graph because there's no work involved. X equals -4 is a vertical line. Okay, these are ones that you need to recognize. They're a lot quicker to graph than any of the others. Alright, I want the equation for the horizontal and the vertical line that contain the point P, which is 3, 2. So the horizontal line goes this way. That is y equals 2. And then the vertical line goes this way. This is x equals 3. So those are the equations of the horizontal and vertical lines that go through that point. Alright, let's try one more. Point is 5, negative 1 this time. Whoops, wrong side. 5, negative 1. Okay, so the horizontal line here, y equals negative 1. Vertical line here, x equals 5. You can pull this straight from the point because it's x equals 5 and y equals negative 1. So you don't even have to graph it. Okay?